Our friend Isaac, you know Isaac Newton, he always used to say that gravity was a force that pulled objects together. But, you know our friend Al, Big Al, Albert Einstein, he always liked to throw a monkey wrench into everything and ruin everybody's life. So here is Einstein's theory of gravity. Einstein said that gravity isn't so much a force as a bending of the fabric of space and time itself around a massive object. We can simulate this pretty easily in the classroom using an elastic sheet and some PVC pipe that's been stretched around in a circle. When a small object passes by a larger object, the larger object isn't going to be affected quite so much by that force of gravity from the smaller object, but a smaller object will pass by trying to take a straight path. It tries to take a straight line. Objects always try to travel in a straight line, but if space itself is curved, then as it passes, the faster it's going, the less it's affected. But the more massive that object in the center is, the more it's affected. When two massive objects pass by each other, it's less that they exert a force on each other and more that they fall into each other's curved space-times, each planet only trying to take the shortest path from its viewpoint. But space itself is curved, so that path becomes curved as well. I want to show also what happens as smaller objects pass each other in the vastness of space. You get much more interesting patterns and dances around each other, chaotic motions of 3 or more planets or stars in orbit around each other, endlessly circling, sometimes colliding. And here we see our black hole. Einstein's theory allows for masses so strong and so dense that even light wouldn't be able to move fast enough to pass by without being affected by gravity. Light, too, wants to travel in a straight line, but if space is curved, it cannot. And so as other objects fall into its orbit, they circle faster and faster and faster, falling deeper and deeper into the orbit, length and time itself stretching out for them. It's only in the last couple of years we learned that these gravitational waves actually exist, ripples through time and space that travel at the speed of light. If this is interesting to you, look into general relativity. I recommend taking that class. It's the hardest class I ever took in college, but it is incredibly cool. Maybe in a future video I'll talk more about special relativity, which is a slightly simpler case of this. Feel free to ask questions in the comments, like this video if you liked it, and hit subscribe if you want to hear more.